let us learn the types of triangles based on sides and angles. There are different criteria for the classifications of the triangles. 1. Depending on lengths of the three sides, there are three types of triangles. 1. Scalene triangle. If lengths of all three sides of a triangle are different, then the triangle is called a scalene triangle. 2. Isosceles triangle. If lengths of any two sides of a triangle are equal, then the triangle is called an isosceles triangle. 3. Equilateral triangle. If the lengths of all the three sides of a triangle are equal, then the triangle is called an equilateral triangle. 2. Depending on the measure of the three angles, there are three types of triangles. 1. Acute angled triangle. If all three angles of a triangle are acute, that its measure is less than 90 degrees, then it is called an acute angled triangle. 2. Right angled triangle. If one of the three angles of a triangle is a right angle that its measure is equal to 90 degrees, then it is called a right angled triangle. There cannot be more than one right angle in a triangle. 3. Obtuse angled triangle. If one of the three angles of a triangle is an obtuse angle that its measure is more than 90 degrees, then it is called an obtuse angled triangle. There cannot be more than one obtuse angle in a triangle. Children, you need to remember some of the following points. 1. An equilateral triangle can also be an isosceles triangle. 2. A right-angled triangle can also be an isosceles triangle. 3. An equilateral triangle is always an equiangular triangle. That is, all three angles of an equilateral triangle are equal with measure 60 degrees each. 4. Sum of all three angles of a triangle is 180 degrees. Let us now learn the new word cevians. A cevian is a line segment which joins a vertex of a triangle with a point on the opposite side. For example, consider a triangle ABC. Take point P on side BC, point Q on side AC, point R on side AB. The segments AP, BQ and CR so drawn are called cevians. Each vertex is having infinitely many cevians. In other words, many cevians can be drawn from each vertex. Some special cevians. Some cevians have its specific names such as median, altitude and angular bisector. 1. Median. Line segment joining a vertex of a triangle to the midpoint of its opposite side is called a median of a triangle. There can be three medians in a triangle. These three medians intersect at a point inside a triangle, and that point is called centroid G. The centroid divides each median in the ratio 2:1. 2. Altitude. The perpendicular distance from a vertex of a triangle to its opposite side is called an altitude or height of a triangle. The opposite side is also termed as the corresponding base of an altitude. There can be three altitudes in a triangle with its corresponding bases. These three altitudes intersect at a point which is called orthocenter O. 3. Angle bisector. Line segments obtained by joining bisectors of the angles of a triangle to its opposite vertex are called angular bisectors of a triangle. Three angular bisectors of a triangle intersect at a point which is called incenter of a triangle. The incenter is the center of the incircle of a triangle. Let us solve some questions from exercise 2.1. Question 1. Measures of angles of a triangle are x, 2x and 3x. What type of triangle is it? Solution. Three angles of the triangle are x, 2x and 3x. We know that the sum of three angles of a triangle is 180 degrees. It means that x plus 2x plus 3x is equal to 180 degrees. It implies that 6x is equal to 180 degrees. That is, x is equal to 180 degrees divided by 6. It gives the value of x as 30 degrees. So measure of angle x is equal to 30 degrees. We got the measure of one of the angles as x is equal to 30 degrees. Measure of second angle 2x is equal to 2 into 30 degrees, which is equal to 60 degrees. Measure of third angle 3x is equal to 3 into 30 degrees, which is equal to 90 degrees. As one of the angles of the given triangle is of 90 degrees measure, the given triangle is a right-angled triangle. When all three angles of a triangle are of different measures, all its sides will also be of different measurements. So, the given triangle is also a scalene triangle. Question 2. The perimeter of an equilateral triangle is 16.5 centimeters. Find the length of its side. Solution. All three sides of an equilateral triangle are equal in length. Let us consider the length of each side as x centimeters. Perimeter of an equilateral triangle is sum of the length of its three sides. That is, x plus x plus x, which is equal to 3x. Perimeter is given as 16.5 centimeters. So, 3x will be equal to 16.5. Therefore, x is equal to 16.5 divided by 3, which is equal to 5.5 centimeters. Thus, the length of the side of the given equilateral triangle is 5.5 centimeters. Question 3. Angles of triangle are in the ratio 3:3:6. Name the type of the triangle. Solution. Angles of a triangle are given in the ratio 3:3:6. Let x be the common multiple of the given ratio. Therefore, measure of angles of the triangle will be 3x, 3x and 6x. It means two angles out of three are of equal measure. This implies that two sides opposite to these angles are also equal. So, the given triangle is an isosceles triangle. We know that sum of the measures of all three angles of a triangle is 180 degrees. Therefore, 3x plus 3x plus 6x will be equal to 180 degrees. This implies 12x is equal to 180 degrees. So, x is equal to 180 degrees divided by 12. So, x is equal to 15 degrees. By substituting the value of x as 15 degrees, we can calculate the measures of angles of the given triangle. Measure of two angles is 3x. Therefore, 3x is equal to 3 into 15 degrees, which is equal to 45 degrees. Measure of the third angle is 6x. Therefore, 6x is equal to 6 into 15 degrees, which is equal to 90 degrees. So this triangle is a right-angled triangle also. Thus, the given triangle is an isosceles right-angled triangle. Question 4. Draw a right-angled triangle. Draw its altitudes where they meet. Solution. Let us draw a right-angled triangle XYZ in which there is 90 degrees at point Y. Step 1. Draw a line segment YZ horizontally. Step 2. Construct an angle of 90 degrees measure at point Y. Step 3. Mark point X on the arm other than YZ of the 90 degrees angle made in step 2 such that length of line segment YZ is equal to the length of line segment XY. Step 4. Join points X and Z to find the third side of the triangle XYZ. We know that a triangle has three altitudes. Line segment XY is an altitude on the base YZ and line segment YZ is an altitude on the base XY, as XY and YZ are perpendicular to each other. For drawing third altitude, we will draw a perpendicular line from vertex Y on line segment XZ, which is meeting line segment XZ at point K. Now take Y as center and a suitable radius. Draw two arcs intersecting XZ at points A and B. Now take A as center and with a radius more than half of segment AB, draw an arc right side of the segment XZ. Then take B as center and with same radius, draw an arc intersecting the previous arc at point C. Now draw a line passing through points Y and C. Name the intersecting point as K. Now line segment YK will be the third altitude. All the three altitudes meet at the point Y. In a right-angled triangle, the altitudes meet at the vertex forming a right angle. Question 5. Draw an equilateral triangle. Draw its altitudes, medians, and angle bisectors. Explain your observation. Solution. Let us draw an equilateral triangle LMN. Mark midpoints of line segments MN, LN, and LM as A, B, and C respectively. Join point L to point A, point M to point B, and point N to point C. Thus we will get line segments LA, MB, and NC as the medians of the equilateral triangle LMN. Point of intersection of these three medians is called centroid, and it is denoted by G. Now when we draw altitudes from the vertices L, M, and N to the sides MN, LN, and LM respectively, and mark the point of intersection of these three altitudes as orthocenter O, we see that the altitudes drawn are superimposing to the three median already drawn, and point O is also concurrent to point G. Similarly, when we draw angle bisectors of all three angles, these bisectors also superimpose on medians or altitudes, and point of intersection of angle bisectors, which is called in-center and shown by point I, is concurrent to G or O. It implies that in an equilateral triangle, medians, altitudes, and angle bisectors are the same, and centroid G, orthocenter O, and in-center I are all concurrent. Observation. The orthocenter O, centroid G and in-center I are all concurrent in an equilateral triangle. Question 6. Draw a median on the non-congruent side of an isosceles triangle. Is it the altitude or an angle bisector too? Solution. Draw an isosceles triangle ABC in which length of side AB is equal to the length of side AC and side BC is the non-congruent side. Let us mark midpoint D of side BC and join vertex A to point D. So line segment AD is the median. If we draw an altitude from the vertex A to the side BC, this vertex is congruent to the median AD, or we can check that median AD is making 90 degrees angle to the side BC. That means median AD is also an altitude of the isosceles triangle ABC. Now, if we bisect angle A of isosceles triangle ABC, again we can see that bisector of the angle A is same as the median AD, or we can check that median AD is bisecting angle A. That means median AD is also the angle bisector of the angle opposite to the non-congruent side BC of isosceles triangle ABC. Thus, a median on the non-congruent side of an isosceles triangle is its altitude and an angle bisector too. Question 7. The perpendicular bisector of sides of a triangle may be or may not be Cevians. Do you agree with the statement? Solution. Yes, the statement is true. Cevians are the line segments joining a point of a side of a triangle to its opposite vertex. In case of equilateral and isosceles triangles, perpendicular bisectors of the sides are Cevians as they meet to the corresponding opposite vertices. But in the case of scalene triangle, perpendicular bisector of the sides do not meet to their corresponding opposite vertices, so they are not Cevians.